Okay, so I should be live now. Let me warn you here. Awesome. I'm going to send an announcement for the entire virtual world, including the other people who are on the other side of the island. I'll just wait for another 5 minutes or so until 12:30 to actually start the lecture. Okay, just hold on in there. Take a seat. All right. Everything is working. I'm even seeing what the people on the north side of the island are chatting. Hello, Erin. You don't actually need to walk all the way to the stage to click the check-in button. You can click it from when you are sitting down. Hello, hello, hello. Welcome. I hope lots of you can hear me and see me on Twitch or in the world. Get comfortable in your chairs. right, everybody, take a seat. Sit down. It's 12:30. I see that. I Hi Ping is stuck on the on the couch under the stage. Hi Ping, if you can hear me, if you just see a chair, just click on the chair. You will be saved from being stuck under the stage. There you go. All right, so I'm going to start the lecture. I already have a good question by Ryan. What do you do if someone claims your treehouse even though you already claimed it? Okay, yes, Jose, I'm also hearing what you said. Everything is much smoother, definitely. So now there's fewer people in each of the simulators, so things should go a little smoother. So let me talk about the logistics. I'm going to start the lecture right now. Okay, welcome everybody. Week 2. Let me talk first about logistics, and I will start with a question here about what you do if somebody put an object on your treehouse that you had already put an object there. And I saw a fair amount of that happening, and probably because people, as you still don't know very well how to move the camera and move around and see things around. So many people went to some treehouse and they didn't see any obvious signs of an object, and so they just placed their own object. So it was not intentional or anything. So today is I'm going to clarify all of the treehouse ownership, okay? And one thing that I was kind of not very worried is that in the first couple of weeks there's always um, a lot of variants. People come and go, people enroll and drop out and things like that. So things now are a little bit more stabilized. There's a few people who dropped out. So now there should definitely be enough tree houses for everybody. That is not to say that some tree house now has 2 objects. So we're going to do something today during class here in the in world that's going to facilitate me kind of purging all of the tree houses that have been claimed by people who dropped the course. So hang in there. And if after this purging it still happens that there's two objects from 2 different people in the same tree house, then it's not a big deal, because then there will be more tree houses available. And one of you, I will actually I can see when the objects were created. I can check exactly the dates that the objects were created, so I can delete the object that was created afterwards, and then that person will have to find another treehouse, of which there should be plenty after today. Okay? Does that answer the question, Ryan? Great. Okay, so first things first, let me just uh, go around here just to remind you again about checking in. Those of you who had already checked in, please don't click the button again, because there's enough entries already in that file. But let me go here and just show you, for those of you who weren't here, where the attendance button is. It's right there, okay, near on top of the unicorn attendance right here. It's this thing. So just click it once, just once, okay? Once is enough. It may be a little slow to give you the acknowledgement that you clicked it because there's many of you here, but once is enough. It will be recorded. Okay, and you don't need to get out of your chair to do it. You can do it from sitting down. Just stay sitting down. This attendance button will be in your view, and you can just click it. No need to be walking around. Of course, if you want to exercise your virtual muscles of your virtual legs, please feel free to do so. Okay, so can everybody see the attendance? Everybody check in. So this is the button. For those of you who are here, please check it in now. For those of you who for some reason cannot be here right now, you have until tonight at 10:30 to come watch the video of this lecture. I'm sorry, do one. Yes, on the north side there is no unicorn. I'm sorry. I only have one copy of the unicorn. So I have to decide where it goes, and it's on the south side. So it's not near the unicorn, but it's on the on the left side of the screen. Okay. I'm going to start moving the unicorn between the south side and the north side. Yes. Okay. All right. So unfortunately, I can hear what people on the north side are saying, but I cannot type to them. But so I can type to them. Hold on just a second. Let me send one last final announcement over here. Here we go. Twitch link. Okay. Twitch link. Here we go. There. Okay. Thank you. Thank you, Arda. Thank you. All right, so there's a check-in. Make sure to check in. The next thing that I want to talk about, also logistics. So here's the thing that we're going to do to purge all the tree houses that now don't have owners. There is this object, this green object on the right side of the stage. Okay, it's called taken, exclamation mark. And I would like you to right-click on this object like this. Let me perhaps, well, right-click on the object, choose More, and then choose Take a Copy. Okay? So again, right-click on the object, choose More, and then Take a Copy up here. All right? So this should put a copy of this object into your inventory. It's going to be somewhere in here in your objects folder. Okay, there should be it's right click. Those of you who have maps, it's not letting you. Okay, let me check. All right, hold on, let me check. I thought I had checked. It should be copied. Okay, I tested it. It's so weird. Okay, so if some people can take a copy, then all of you should be able to take a copy. Yes, if you have, if exactly, on the Mac it's a little different. Those of you who are working on the Mac, the right click on the Mac is some combination of left of the only click that you have and Control or Alt or something like that. Can anybody who has a Mac and already figured it out explain how to right click? Okay, it's not the take option. It's definitely not the take option. Okay, it's not the take option. It's a more. The first level is more. Okay, and the second level is take copy. Okay, it's not the immediate take that you get when you right click. It's not the first take that you see. Okay, it's first you say more and then you say take copy. Okay, take copy is grayed out. All right. Okay, so maybe, all right. So it looks like there's some general consensus that if you stand up out of the chair, apparently it works. I don't know why that would be the case. Okay. Oh, I got it. Okay. You know what? I know what's going on. It's some of your limitations of the viewer configurations of how far you can be to be able to actually do something on an object. That's what's going on. So I'm sorry. So let me reset. You should stand up. If you cannot grab it, if you should stand up, go closer to the object and do what I just said. Yeah, I'm sorry. There's a configuration on the viewer that is about how far you can be in order to do things on the objects, and I did not tell you to change that configuration, so most of you have the default one, and it's relatively a short distance. Yeah. Okay. So it's fun, just exercising your virtual legs a little bit, gymnastics instead of sitting down all the time. All right. So grab that object. Excellent. All right. And go back to your seat again. And this is the object that we're going to use when we go. Um, so when you do, okay, Mohammed, what you do after take a copy, just hold on to it, okay? After take a copy, this will go into a folder in your inventory called objects. So if you open your inventory here, you will see it there, under the objects folder. Okay, and there should be an object there. Just leave it there, okay, for now. I'm going to tell you how to use it during the breakout. We'll do a little breakout during this lecture, and you're going to basically put this object on your parcel so that I know that that parcel is taken by somebody who's been here today. Okay, the inventory button is this suitcase button on the bottom right. There's a suitcase on the bottom right. There's the inventory button. All right, so I assume that everybody has got their copy of the green orb over here, and you can just sit down back again so that you can have your camera pointing. Yes, Nicholas. Um, all right, so just hold on to that object. We'll use it in a few minutes. Harry, it's in a folder called Objects. If you open your inventory, there's a folder called Objects. The other way, yeah. So Xiomara, if it's not under Objects, it's either because you're searching for some keyword that is filtering it out. Right, somebody's wearing it. So if somebody is wearing, try clicking on it and drop and just unwearing it. Take it off. It will show up in the inventory. So, and if on the other hand, if you don't see it in your inventory, you can just go take another copy if you really want to, but you don't have to. It should be in your inventory. Okay, let me see who is wearing. Okay, so whoever was already took it out. That's good. Okay, so let's move on. I will help somebody. Okay, great, Lenny. I will help people during the breakout if somebody needs help on this. Okay, just hold on. It's in your inventory. The one. Don't worry. It's okay. We'll fix it during the breakout. So what I want to talk about next is actually going into the content of this course. I'm going to talk about computing machines, and for a little bit, about 20 minutes, I'll just give a small lecture, and then we'll have a breakout in which you are all going to your treehouse, do certain things, and then we'll come back over here to the auditorium, okay? So that's what's going to happen in the next hour or so. So let me go back here to yes, this meeting is recorded, Bevan. I am recording this. I'm live streaming, so this will be recorded in in Twitch, and then I will upload it to YouTube. So you can watch it a little later, both on Twitch while it's still there, and on YouTube. It's going to be there forever. Yes. Okay. So here's what I want to talk about, the content of this course. So this course is about how computers work and give you an idea of what is a computer, how does it work. So this week we started already with some content related to that. I asked you to watch a bunch of videos, really good videos about the early history of computing, um, things like the abacus and where this idea of computing comes from, how people try to build mechanical machines to do automatic calculations. Basically, idea here, if you watch the videos, I'm just going to kind of summarize it. You are in 1580. Okay, you're a person in 1580. You want to do some calculations. Maybe you're a scientist at the time, and you don't have a calculator. You don't have a cell phone, right? So you don't have this. And so if you want to calculate, for example, the logarithm of 356, the only way that you can do that is by, with your stylus and your some paper, and just do it by hand. That's the only way that you can do that. Um, uh, so that was the state of the art for a very long time, right? Until inventors started having some thoughts about what could you do to make things a little easier, to maybe start with the abacus. The abacus already gave some hints about what could be done, but it still was moved by human power, right? It was powered by the human fingers. It's powered by the human fingers. But so people started thinking, okay, so can we do some machine that is powered not by human fingers? Maybe the human does some, clicks something, does something, but the complicated thing is done automatically. For example, how to deal with the carry and things like that is done automatically. And so that's created a whole door of inventions for doing mechanical calculators, of which you saw hopefully some of these videos, right? And there was really interesting designs being tried out and deployed at the time. Things like the Pascal machine, the arithmometer. So it's really interesting things. I hope you guys have enjoyed those videos. I enjoy these things very much. It's ingenious. It's basically, somebody sitting thinking, how am I going to do this particular, rod over here so that it carries the leftover from adding one number to another, for example. It's a really interesting thing for those people who have these uh, tendencies of trying to solve things by engineering, right? Um, but so at some point around the mid 1800s, then there was something that I also had these videos over here, which was Babbage. Babbage's machines were really amazing. Okay, of course he didn't really build them. They existed only on paper. He built some small parts of it here and there, but he didn't build the entire thing because, as you can imagine, he was really very ambitious in his design. And this picture that I have over here in this video really shows the scope of his ambition. The idea is that to have this massive, gigantic mechanical monster of 7 meters long, I think it was the original design, um, full of mechanical pieces, right? These are mechanical pieces. Remember, this is 1830. Electricity had not been invented at the time. So all you had at your disposal was the power of mechanicals, of hardware touching each other, right? So rods and things like that. So that's sort of how he would envision having a calculator that was working via these mechanical pieces, right? They all touch each other in specific, very well controlled and well designed and carefully thought of ways. And so the way that he thought about is that while you have some sort of a memory bank, right? This is where you would store the temporary values of some calculations, and you would have sort of a central control that's sort of the rounded area on top of this machine where the there would be a program that people would be able to input via these punch cards. And that program was specifying what operation do you want to do. For example, logarithm of 356, for example, or square root of 1032. And that program, the program was about how to move these pieces, right? How to what it would have to be broken down in, okay, uh, grab that value that's sitting over there, put it in this register over here, rotate things by 3 times, so there will be a sort of a mapping between the higher level operation that we wanted to do and the physical, mechanical movements of these parts of the machine. That was the idea. And so, as you probably saw in these videos, a friend of Babbage, that was Lady Ada Lovelace, she was working with him and kind of developing these ideas. In particular, she developed this idea of the program. The program is a specification that is given from the outside, and it's given in terms of what pieces of the machine you need to move in order to obtain the result of the calculation that you want to obtain. So that's considered the beginning of programming in a way. So this is all really fascinating, and so, even more so because he envisioned all of this machinery in a time where there was no electricity, right? There was no electricity, so it was very Victorian in this way. It was sort of steampunk, right? It's like this idea of these gigantic machines that are mechanical, and that will do something that turned out to be a really good idea. It's just it was the wrong technology, right? So mechanical pieces it's just there's so much that you can do. It's very complicated to design something with mechanical pieces, like with thousands of mechanical pieces, like the Babbage envisioned at the time. But because it did not have electricity, that was the only way that he could imagine or conceive of what the calculator might look like. Um, so there's also a part about human computers. In the absence of computing machines, of which there were none, or there were very little. There were just the smaller mechanical calculators that did just a few operations. Addition, multiplication, division, subtraction, things like that. So as more and more of modern life required calculations for interest rate calculations, when the war came around to calculate the angles of how do you shoot the cannons and things like that. So there was a lot of scientific and engineering need for calculations. And so in America in particular, there was a period of time of 10 years there between 38 and 48 where there was the dawn of computers. Okay, there was the dawn of actual electronic computers, but there were no computers as such. They were just being invented at the time. But there was already a very strong need for these automatic calculators. So what they did is that they hired a bunch of people, literally some of them off the streets, as long as they were good at math and they could do calculations very fast. That was their role. They spent 8 hours or whatever number of hours a day. Their role was to make calculations the entire day. These were called the computers. They were called, literally, the word computer comes from here, from human computers, human people who were just doing square roots and logarithms and all sorts of differential equations. So that was kind of an interesting thing. Of course, the human computers were immediately replaced when people were able to actually make machines that did what these people were doing. And so that leads me to today's lecture, and also the videos that you are going to watch next Tuesday on computing machines. So remember the where we came from in um, so far in the videos that you watch was the dawn of computers, right? It's what people have done all the way to around 19 the mid just before the Second World War, which was trying very hard to make mechanical computers work. Of course, it's super hard because designing those pieces, they are bulky, they just they break all the time. You need thousands of them, So that was not very scalable. So that didn't work. So they put people, and that kind of worked for a little bit. And then they finally made electricity came around, and they were able to make computers out of electromechanical components first. And so that's what you're going to hear a little bit on the videos on Tuesday. But in the meantime, what I want to talk about today is that right at the dawn of starting this idea of the computers, the electromechanical computers, and then the electronic computers entirely, that's when things really changed really, really, really quickly. So that was around, in 1940s. In 1940s, that's when the first real computers were designed and deployed. Actually, they were deployed in time, some of them for the end of the Second World War, and then from then on they were employed in business, for banking applications, military applications, all sorts of interesting applications. They were still thought out in the beginning to do calculations. That was their main goal, was to do these calculations. But soon enough, people started being a little bit more creative and started realizing that you can encode a lot of things in numbers. And then once you have that encoding, this computer becomes something really, really powerful and sort of very general purpose, because it's not just about resolving differential equations, or not about just finding the square roots of some numbers. It's actually doing interesting manipulations of data, where the data represents all sorts of things. Can represent images, can represent music, can represent all sorts of things. And that is really the beginning of broadening the applications of computers. And we'll talk about that a little bit when I talk about data representations. But so what I want to talk about today is just to let you know that on Tuesday, you can start already watching these videos if you want, and doing the quiz. I already also made the quiz available. This is a set of videos that kind of explains what the dawn of the electronic computing and what an electronic digital computer really is. Okay, so there's a bunch of really good videos over here from I think PBS, that explains what is a computer. These are all the videos that you really should watch. Okay, so today I'm going to give you a little preview of what you're going to watch in those videos, and also the subject matter of your next or first project that is also already available, which is the computing machine. So I'm going to talk about a computing machine that I have done here in this virtual world. It simulates the simplest and most straightforward computing machine that really represents the computers that people have designed back in the 1940s, and to some extent it still represents the modern computers. This is still how computers work. The computers that you are using right now, the laptops, of course, all the components have been shrunk, right? It's super, super small now. They're not those big things that Babbage thought. They're not the big electromechanical things that in the 40s. They're really, really, really small. But conceptually, the architecture is still the same. So this is what I want to show you, the computing machine. So meet your first computer. And this is a simulated computer. And I'm going to explain the different parts. This is where you're going to do your first project. And this is great that it's simulated, because it's great because I can make this computer as simple as I want it to be. The real computers out there tend to be a little bit more complicated because they are for production purposes, not for teaching purposes. But I can make this relatively simple for everybody to understand how a computer works. And we don't need to have access to an actual physical laboratory to exercise this machine. It's a simulated machine, and it works perfectly fine in here. So let me show you how I'm going to. And I would appreciate right now, I know that some of you are clicking the computing machine. So if you just don't click the computing machine, that's pretty great. People are clicking it. I can see the error messages over here. So just don't click it. Let me show you. I have placed one of these in every tree house, so there's plenty of machines in the world for you to try out. In fact, that's what's going to happen during our breakout. So let me show you the best way to interact here is to go to, I put a chair to, as usual, whenever I put chairs, it's because it puts your camera in the right way. So that's, so that, you know, moving the camera can be complicated. So if you sit down, it just, you know, centers your camera and you're looking directly at the machine. So let me explain to you what a computer machine is. And first I'm going to explain the different parts, all right? And I will relate this with some of the things that you heard, for example, in the video about the Babbage machine, which is, you know, in many ways not that different. It's just that it's, you know, different hardware or different simulated hardware. So on top over here, on top over here, you have the input of the user. So this is where you input some numbers. Maybe, you know, if you click it, this changes, and it's only one direction. So if you click 1, if you want to go back to 0, you have to click it all the way back to 0 again. Okay, so this is a number. That this is going to be the input, that if the program of the machine is asking of some number as input, you have to input the number here and then click the enter. Okay, so this part here is like the keyboard. I should be calling this the keyboard, right? The keyboard up here. All right, so that's the keyboard, and now there's the display. The display is down here. Okay, this is the display. This is not interactive because it's just a display. You're not supposed to change anything. The display is something that the computer is going to control and put something here when it has something to show you. Right, so at the bottom, there's going to be the output, the display. All right, so input on top, output on the bottom. Let me show you now on the left. On the left side, there's a bunch of lots and lots of little small zeros right now on a sort of a brownish panel thing. This part on the left is going to be the memory. What is the memory? The memory is it's called the RAM, the random access memory. It's a piece of hardware. It's like Babbage's long tail of that machine. Okay, remember that long tail that was like 7 meters long, Babbage? Okay, this is what it is. This is just a bank of hardware, some sort of hardware that stores values. Okay, and it stores values while the machine is working. Okay, when you unplug the machine, these values are all erased. Okay, this is only valid while the machine is working. It's not long-term storage. It's not like the hard drive. Okay, the hard drive, actually, my computing machine here does not have a hard drive. All right, so that's it all. So, but it does have memory. Okay, memory is something that sits on the board, right, of the computer. You can add more memory chips to it. And it's basically like that long tail of Babbage's machine. It holds on to certain values whenever we want it to hold on to those values, okay? So this is the memory. This memory of this simulated machine consists of exactly 16 rows, okay? And that's just because I decided that 16 would be enough for the kinds of programs that you're going to write. So it has 16 rows, and each row has 8 digits. And all of these digits are decimal. I didn't, you know, I just put, these are the normal numbers that you all know, okay, from 0 to 9. So you can represent numbers over here up to 99,999,999, okay? That's how the range of these memory cells. So basically each row I call a memory cell, and it holds one value. So each row can hold exactly one value that can be between 0 and 99 million and 999. All right, so this is the memory over here. The central part over here is the critical part. The central part is the central processing unit, and rightly so, it's in the center. Okay, the central processing unit is the core of a computer. It's called a CPU. All of your computers, the laptops that you guys are using, you all have CPUs in there. What does the CPU do? What's its role? Well, the CPU is really the thing that controls the machine, right? So somewhere in here, there's going to be a mechanism that is going to be able to read some program that we give it that is going to be able to read input if we want to read input, that's going to be able to write the output when we want to write the output. It's going to be able to change these memory cells with new values or read the values of the memory cells. So this is all done here. The core of the computing machine is this CPU, okay? And embedded in the CPU, there are a few parts that are important. One of these parts is these registers. They are in this case, I have done only 3 registers. That's just because, okay, just didn't have space for more. I could have put 4, but it's just, ad hoc number. In practice, your modern computers have a lot more registers than this, than 3. But this is, again, enough for the kinds of programs that you will be writing with this machine. What are these registers? So these registers are sort of similar to the memory cells. In many respects, they are like memory cells, except that they sit right on the CPU. So they are part of the central processing unit. And they are here as the devices where the central computing, the CPU is going to make operations. So for example, if you want to add 2 numbers, those 2 numbers must be brought here into the registers to being added, okay? If you want to multiply them or whatever. Whenever you want to do some operation on some numbers, then those numbers need to come to the registers, okay? The CPU cannot do operations directly on things that are in memory. They have to be brought from memory to these registers, and then that's when the CPU can actually do things on them, okay? And the same, conversely, once you're done with some operation, if you want to store it, then you have to load it back into the memory. You have to store it into the memory, the RAM, okay? And that's where it will be there for you to fetch it later. But so these registers are like memory cells, but they are used by the CPU to do the operations that the CPU needs to do, and then they can be offloaded into memory, or the memory can be loaded onto them. Okay, this is an important part, the registers. This panel over here, this white panel over here, that right now it doesn't have anything, but as you see, it kind of looks very similar. I give it the same look and feel as the memory on the left. The thing on the right is also sort of like a memory, and it is a memory, but it plays a special role. This is the memory that is going to store a program. So whatever it is that we want to run, it's going to be stored in here. So this is memory. It's part of the memory. I just did not represent it in zeros, in numbers like this, because that would be a little too low level, okay? I want to show the program in a way that is slightly higher level than just numbers. So because of that, I didn't put all these little numbers over here. But this is this is memory, okay? It just holds on to things that are going to be the program that the machine is going to run, okay? And I'll show you how to load the program over here. And then there's these buttons over down here that many of you already tried out to reset the machine, or play by stepping, instruction by instruction, or play the whole thing from beginning to end. That's the play over here. So now let me show you. Okay, the other thing that also comes in the package that I placed in your treehouse is this yellow box over here. Sorry, I'm in the middle of it. Okay, do you see this yellow box over here? All right, this yellow box on the right, I added it there. It's not part of the machine. It's just a box that has example programs. So if you click it, it will give you here a folder called example programs that you should accept. All right, so if you accept it, then something in your inventory shows up here, example programs there, example programs, all right? And then you have a bunch of example programs over here to start off. So let me show you what the program looks like for this machine. And then again, I'm going to give you more lectures about these instructions and what exactly are these instructions. But here's the program. Oh, this is complicated. Average. Okay, so here's a program that computes the average of 3 numbers. Okay, and I don't know if you can see this. increase the font. I don't think I can increase the font. But anyway, I'll tell you what this is in here. It first says read in to R0, and then read in to R1, and then read in to R2, and then add R2 to R1, add R1 to R0, and then says set R1 to 3, divide R0 to R1. Don't worry, I'll explain this. It's just to tell you the kinds of instructions. Basically, it's instructions to read the data, add numbers, dividing numbers, and then write data out eventually, okay? So the way that this is going to work, I'm going to show you. Please don't touch this machine that's here on the South Auditorium. So I'm going to take this program over here from my inventory, and I'm just going to click it and drag it, okay? I'm going to drag it over here. All right, and this will show up what this program is. It's a copy of exactly what's in here. It will show up in here, all right? And now I can run it. So I'm going to run it step by step, okay? I'm going to, and you'll see this red marker over here moving as I go along. So let me start here, step by step. So I click here, step, and now this button lights up because it's a read instruction. So I'm supposed to read something from the keyboard. So let me read let me change some number over here, and I say enter. When I say enter, you notice that this number that I entered was placed here on R0, right? That was the instruction, read in and place the number in R0. There it is, okay? And now it's waiting for, did somebody already click something? Go here. Hello, okay, I don't know what happened. Let me start again. So reading over here, step. Oh, I need to step. I'm sorry. That's right. I need to step. So I'll go here, and it's now I need to step again. Okay, I'm going to step again, and now it's going to light up. It's waiting for me to read something again. Okay, to input something. So let me put this number, enter. It moves to the next line. I need to step to it. Okay, and it's put something here, enter. So now I enter the three numbers. You can see that the instructions was to put the first one on R0, the second one on R1, and the third one on R2. Those are the instructions. And here they are. So now I'm going to continue. Well, the next instruction is add R2 with R1. So it's going to add these two numbers. And according to these instructions that I explain a little better later on today, the result's going to be placed on the last register. So if I say add R2 to R1, it adds, and then the result's going to be placed on R1 because it's the last, the second register. So let me step, okay? So there it is. It's the sum of the R0 to R1, or whatever it was. And then I'm going to step again, add R1 to R0. So now the sum is going to be placed in R0. There, we have here the add of the three numbers. And then I'm going to do something. We have three numbers, so I have to divide by 3. So I'm going to put the number 3 in R1. There it is. The number 3 is in R1. Now I'm going to divide R0, which is the sum, by 3. So divide R0 by R1, and the result is going to be placed in R1. There. So this is the division by 3. And now I'm going to write out R1. This is where I'm going to put the result here on the display. There. Okay? And we've reached the end of the program. All right, so this is an example of a program that, of course, you can also run it, just by clicking run. And in this case, it just runs without you having to click go every time. Right, it just runs by itself and then produces the results at the end. Okay, so this is a computing machine. Again, I will explain. I will continue to explain as we go along. But basically, the input or the keyboard is on top. The output or the display is on the bottom. The memory that I haven't explained very well yet is on the right. We haven't used it in this program. We don't need it. It's on the right. The CPU is in the middle with its registers, the important registers where all the calculations are going to be made. In the videos that you're going to watch, that I put it there, you will be told about the arithmetic and logic unit, and that's the one that is sort of part of the CPU. It's a little separate. It's a separate component of the CPU, but it's part of the central control unit. It's the actual part of the control unit where these operations are actually done. Okay. So in this machine, I just merged the two. Okay, the ALU is called the ALU, the arithmetic and logic unit, is part of the CPU, so I just put it here, okay? But in just a little warning that in the videos she's going to talk about separately from the ALU and the CPU, and I just merged the two over here. And then the memory where you put the program, and if you want to wipe out the program, if you want to reset this, you click reset. If you want to wipe out the program, you just click here and the program disappears, okay? This is where you just reset it and then you can load another program. All right? So this is your first introduction of what a computer is. This is it. And let me tell you, your computers these days, the things that you are using right now to watch me here, are much more sophisticated. The components are much smaller. You cannot see them. You cannot see things that I'm showing you here. But conceptually, it's very similar. It's basically this is it. Okay. Of course, there's a lot more memory. Of course, there's a lot more registers. Of course, the machine is your computers are a lot faster than this one. Okay, this one is really slow on purpose. But you know it's not that different. Conceptually, the architecture is very similar. Continues to be this sort of architecture and these kinds of hardware components. Okay, so let me stand and we go into the part of the lecture now that I would like you to do a little activity and exercise your avatar legs. And let me tell you before we go on the breakout. Let me tell you what I would like you to do. It's two things for about 20 minutes. So I'll be timing. We'll come back around, you know, I don't know, 1:35 or 1:40, something like that. Maybe 1:35. Maybe 15 minutes will be enough. The first thing that I would like you to do is so you go back to your treehouse and you do put that green object on your lawn. Okay, that is important. But by the end of today, I will make a survey of all the tree houses, and the ones that I don't see a green marker in there, I will consider that they have been abandoned. Okay, and I will reclaim them to myself, and then other students that are still looking for tree houses can use them. So please put the object that you just taken. So how do you do that? You go here to where you gotten your object, okay, in the objects folder, and you basically drag it. So you take this object and you just drag it onto the world. You just drag it there, okay? And then it will create the object over here. Okay, so let me delete this. But that's how you do it. You find it on the folder over here and drag it onto the floor. Make sure that you drag it onto somewhere on your lawn, okay? So this is the first thing I want you to do. The second thing I want you to do on your treehouse is to then sit on your computing machine that is there on the treehouse and do what I just did. So sit down, get the example programs into your inventory, and again, this is done by just left click on the yellow box. It will give you some folder that you accept. The folder is called example programs. So you'll find your folder somewhere in your inventory, and you have a bunch of examples, and then drag one of the programs onto the memory that is the program memory, and then just play around a little bit with it, okay? And when I think that everybody's ready, I will send out a general announcement over, you know, the world messaging thing that is going to show up, you know, on somewhere on your example of an announcement. Okay, to show up over here on your right, so keep an eye for that. I will call you back to the auditorium, okay, in about 15 minutes, 15 to 20 minutes. So go to your treehouse, put the marker, play with the computing machine, and then watch for the announcement for you to come back over here, all right? See you soon. Solan, so it not remember where your house is. Well, you'll just have to remember. So if you have some problems finding your tree house, you can just, of course, you cannot put the green marker if you don't know where your tree house is. So you're just gonna have to wait until tonight to reclaim another tree house. And the other thing is that if you want to do this with a partner or with a friend, if you guys have friends in here, you can just do go experiment with the computing machine together if you want. All right. In the meantime, what I'm going to be streaming is just me poking and seeing what people are doing. So let me just poke around, see where people are, and check what they're doing. Okay, I see lots of markers already. Awesome. Lots of green markers. Very good. Very good. Oh no, Peter. Is that right? Did I not show? No. No, Peter, is that right? Was I not showing the computer machine as I was talking about it? Ah. Okay. Fail on OBS. All right. Let me go back here. Hold on. Let me just do it again. I will do it very quickly. Now that you are seeing over here. Maybe the people on the north side didn't see it because you guys on the south side saw me sitting down. Yeah, but the north on the south side you saw me in the machine, but on the north side, okay, all right, but I'll do it again. If you already saw it, please go back to your tree house. If you didn't see it, I'm going to do it again. Okay? So here's what I'm going to do. I'm going to sit down over here. This positions the camera in the right place for operating the machine. Okay. I think it was the people on the north side that didn't see it because I don't have a computing machine on the north side auditorium. So I'm going, as I said, if you already saw it, go back to your treehouse. If you didn't see it, I'm just going to do it again during the first minutes of the breakout. Okay, so what I was saying, talking about, the top is the input or the keyboard. All right, the bottom is the display, the output. All right, the left side is the memory, the RAM. So you can see these memory cells of like 8 digits each one. There's like 16 of them because that's what it fit here on this panel. So you can store up to 16 numbers, each one up to 99,999,999. The middle part is the CPU, the central processing unit. And my CPU in this machine is a mixture of the CPU and the arithmetic and logic unit that you'll see in the videos. It has 3 registers. The registers are, whenever you want to do some calculations, you need to have the numbers in these registers, okay? There's no such thing as doing calculations of numbers that are in memory. First, you have to bring the numbers from memory to the central, the arithmetic unit and logic unit, and then you can do the calculations over here. And then when you're done, you can store the results back in memory. And the right panel is the program memory. This is where you load the programs. And that's it. And there's some buttons that you can reset it, and you can step. This is a step button, and this is the play button. And the box that I was saying is this yellow box over here. Each one of you has a yellow box, this yellow box, okay? And the yellow box is not part of the machine, it just has a bunch of example programs. So you want to click it, and it will give you a hold on. So I have a question from Edward. Where will the new tree houses be located? At the end of today, I will put a bunch of red markers on tree houses that are going to be free, okay? So look up today, at the end of the day, for the red versions of these markers, it means that the tree house is free and you can grab it. Okay. Okay, so for that machine, your character and the box does not show on my screen. Okay, the Peter, my character does not show because that's the way that I position the camera. So if I stand up, here's my character, okay, my avatar. If I sit down, I position the camera so that I don't care about my avatar. I just care about the machine. So I just focus on the machine, all right? I don't care about seeing my head in here, just the machine. The box, I'm sorry, the box is here, all right? It's this yellow box over here. And if you click it, it will give you something, okay? And, which is a folder, and you should accept this folder, all right? And then the folder will show up in your inventory, and it's called example programs. Noel, how to place the green object? You go here, it's in your inventory, under objects, and you just drag it from your inventory onto the floor or the lawn, okay? You just drag it into the lawn. Just don't drag it to you, drag it onto the lawn. So if you are wearing it, okay, if you are wearing it, just unwear it and do it again. Okay, so continuing here, this is the part where you're going to download some programs. So let me go here, grab a program from these example programs, for example, the average. So the way that I do it is I click on the average note, it's called a note card over here. It's just a text file, okay? And I'm going to drag it onto this panel. It takes a few seconds, but then you'll see that the program has been loaded and you can read it here on the machine. Okay, and then once you have it here, then you can either step by step. So here's the first number thing that I'm supposed to enter. Here's I'm supposed to enter a second number, enter, and then the third number, enter again, and then this is going to add two things. This is going to add two other things. Oh, it's slow now because a lot of people are doing things on this simulator. And then it's going to hopefully add more things. Hello, machine. Will you come back to me? There you go. And then it's going to divide. And then it's going to write out the result. Okay? So this is how you load the program. We drag it from your inventory onto this panel. And then if you want to get rid of the program, you just click on this panel. Before you get rid of the program, if you want to run the program again, you can just say reset over here and it goes back to the beginning. And if you want to get rid of the program, then you just click on this panel and it just disappears, okay? Then you can drag another program. Okay, sorry people on the north side that I was not streaming this scene over here. So I want you to go to your lawn, put the green marker and play around with the computing machine that's in your lawn. And now let me see what people are doing. All right, green markers. Okay. Awesome. So if you're listening to me, some of these tree houses that there's no green markers, by the end of today, so some of you who are not here, you still have until 10:30 to put a green marker in the tree house if this is your house. Otherwise, I will come here later tonight or early tomorrow morning and I will clean up the object and put a red marker on the lawn so that other people can claim it. Another thing, I don't know if some of you already noticed or not, but your lawn, so inside of your lawn and your treehouse, so inside of this space over here, you can talk over voice. So if you are working with somebody else, if you just are doing things together, exploring things together, you can actually talk over voice. So in order to do that, you can, well, I'm not step. Let me go to a place that actually has voice. Let me go somewhere that has voice. Let me go. Wow, look at this. It's so pretty. You're all distributed. Very nice. So let me go here, maybe to the TA, or maybe just, where am I? Here, let me go to a treehouse here. All right, so if you see here, I have a white dot on top of my head. What that means in this world is that I'm connected to a voice channel. So if other people are here on this same lawn, on this same tree house, we can talk. And the way to do that is there's a microphone button down here, see? And if you check the check mark, so that you can click this microphone button, it opens, and now I have these green bubbles on top of my head. I don't know if you see it. These green bubbles on top of my head, it means that this viewer is recognizing that I'm talking, and the other people here should be able to hear me. Okay, and when you want to mute the microphone, then you go here and you just mute the microphone. All right, it's very convenient to working together, talking with the TA. If if you have questions about how to use a machine, the TAs have a machine also in their tree houses. You can go there and talk to them while you debug whatever program you are debugging. Let me go back. When I step off of these lawns, there is no voice anywhere. You see the little white dot disappears. I don't have the voice enabled. I'll just fly there. Oof. Great. I see that people are already trying to do divisions by zero. Awesome. Yes, Kathleen, I'm hearing. Where is the folder with all the programs located? Okay, great. So if you go here on your inventory, there should be a folder called example programs. I'll tell you if you don't see it, because sometimes it's hard to see. A trick that you can do up here. You see this? There's the inventory. If you see recent, okay, if you click on recent, you'll see what has been recently placed in your inventory. So it will be perhaps easier to see what you just got recently. Okay, so that's a trick that you can do. Go to recent and you'll see what got recently into your inventory. Otherwise, in your whole inventory, that's something that should be called example programs. And this is a folder that gets given to you by this yellow box. This yellow box, if you click it, left click it. Yes, okay, Kathleen, it's a yellow box. So any yellow box, there's not one in your auditorium, but if you go to the tree houses, there's yellow boxes everywhere. So you just click one of them, and it will give it the example programs. You are welcome. All right, I'm going to call everybody back in. Let me send a message. Nice to see everybody arriving back. Looks like the communications are working well. Very good. Make sure that you have your media still playing and you're still watching me live streaming. Okay, great. So I am going to do the next 5-10 minutes, the last 5 to 10 minutes of this lecture. I'm just going to tell you a little bit about these mysterious things. Exactly. So Bevan's already asking, if I want to write my own program, how can I open the text box? Exactly. That's exactly what I'm going to explain, Bevan. Thank you for asking. So, you're sitting on your chair. Well, whatever. I'm just going to put a little perspective over here. Here's how you do if you want to create your own program. So you go to your inventory, and now you can basically what you need to do is to create a note card. But let me give you some advice. You can either create it here on the folder that you just received, or you should probably create a new folder. That's what I would do. And to create a new folder, you go here to the top of the inventory, you right click it, and then you say create folder, new folder, okay? And this creates a folder somewhere, and you call it, programs, all right? So now you have a folder where you're going to have your programs, the ones that you write. And how do you do that? You right click on this folder, and now you say new note card. All right, so you say new note card, you call it, program one or whatever other name you want to call it. And now you have a text file over here. It's just a text file that you write, for example, read in a number to R0, and then maybe you read in another number to R1. Actually, within R0, I'm going to divide this number by 1000. So I'm going to say set R1 to 1000, and then I'm going to say divide R0 by R1, and then I'm going to say write out R1. Let's see if this works. This is me live coding a computing machine over here. So after you do that, make sure to save it. All right, so save it here. There's the saving button over here. Don't forget to save it. And then you can just close the window if you want. And then once you have the program over here, then you do the same thing, right? So you drag it from your inventory, program one, into this panel over here, all right? And it shows up in there. It escaped so it shows better. So that's the program that I just wrote. Read into R0, set R1 to 1000, divide R0 by R1, and write out the results. So let me run this. So if I click run, it waits for me to read. So I say enter, and then it continues. And you guys didn't even see what happened. Let me let me step. I would advise you to step in the first programs that you write, okay? Because then you follow very, very slowly what is really going on. So let me step a step. This is waiting for me to enter some number. So let me enter 9,841. And then I'm going to step again. I'm sorry, I have to click enter. And then it's going to set R1 to 1000. Okay, there it is. Then it's going to divide R0 by R1, and place the results going to be placed on R1, and then it's going to write the results at the end. Okay, and if you want to start it again, you click the reset. If you want to get rid of it, you click on this panel. So just to say this again, go into your inventory, create a folder, and you do that by right-clicking on the top of the inventory, and you say new folder, call it programs, and then inside the programs folder, you right-click the programs folder, you say new note card, okay? This shows up a text file, you call it another program 2, whatever, this is another thing, and then you write your program here, you save it, and then and you can always open the ones that you had before, right? So this is the one that I just wrote, and change it if you want. So to make changes to your program, you change it here in the note card, okay? Save it, and for example, suppose that I actually want to divide by 100. I change that, I save, and then I can remove this one, and then move this one back in. Okay, so this is the question: how do you write your own programs? You use these note cards. You just add the programs there. So, but the other thing that I want to start getting into a little bit more, and I'll go more into detail on next week, is these programs. What are these programs? What is this, right? What is going on? So these programs are written in this language that I just made up, but it's a language that is very similar to many what's called assembly languages, are low-level languages. And what these languages refer to is basically doing, like the Babbage manipulation things, that you move one thing from that big tail of the machine somewhere to the central unit and back again. So that's basically what is going on. You're going to encounter to have here a bunch of instructions that are going to allow you to move numbers around. So move numbers from the input to the registers, from the registers to the memory, from the memory back to the registers, from the registers to the display. Yes, so the caller is asking, is there a README that has all of the language for reference? Yes, those are called the instruction set, and let me show you where you can find it. So let me put this here. let me go back here. If you go to the syllabus, but go to the assignments. So the projects that you can already start thinking about to do is this one, computing machine. You need to do these 3 programs, all right? But then there's also here the complete instruction set, which is a page that you may be able to find somewhere, but this is how I find it. So the complete instruction set of the machine is here. And here's what it can do. So there's arithmetic operations. There's some other registers operations like copy the value of a register to another, or set the value of a register to a certain value. Then there's memory operations like fetch something from some address and put it in a certain register. This is fetch star. I will explain a little bit more, not today, what fetch star is, and store star. And also the branching, I'm not going to talk about it today. I will maybe tape a video, and then next week I will also talk here live about these branching instructions that are a very important part of programming. And then there's the input output. For now, it's just read in and write out. Soon we'll also have the ability to write onto a network card that I'm going to add to this machine. But basically, this is the complete instruction set of things that you can do. For now, so the arithmetic operations are the easy ones, super easy ones. You'll see, I encourage you to write simple programs that are basically just calculators, right? And then if you want to start playing around with putting things in memory or fetching things from memory back again, this is the memory operations. And then this is the part that may be complicated for many of you, which is the branching, but I will have to explain that, not in 2 minutes. Any other questions? All right, so the project that you can start already doing or thinking about it or trying things out is to compute the average. It's these 3 programs. The average, which is computing the average of a set of values entered by the user. So the input values should be accepted until the user enters 0. So the idea, and this already requires some branching operations. So I will... Yes, so will there be, there's a question here from Brandon. Will there be videos about how to do the project? I am going to tape a video about how to exercise all of these instructions, the complete instruction set, okay? And I'll explain, especially the branching operations are super important and can be very confusing because they're very foreign. So I will explain how to use the branching operations. So one of the first program is to do an average, but you keep accepting input until the user enters a 0, and then you average the whole thing. The other one is computing the maximum of a set of values. Again, same thing. The user enters a set of values until it enters a 0, and then you have to compute the maximum of the values that the user has entered. And then the final one is the Fibonacci sequence. So we write a program that generates the first n numbers of a Fibonacci sequence. Fibonacci sequence is something very cool, that it's something that starts at 0, 1, and then it's 1, and then it's 1 plus 1, 2, and then it's 2 plus 1, 3, and then it's 3 plus 2, 5, and then it's 5 plus 3, 8. So it's always the sum of the previous 2 numbers. It's a kind of a funny thing. So there's more questions. Is everyone in the Discord server? Okay, this is a question for you because I'm not invited for your Discord server, so I don't know. All right, so if you guys, there's a Discord server that is totally run by you students. I am not invited, so feel free to join that. Somebody typed it, but it's only available on the north side, so I'm going to type it here so that it's also available on the south side. That's the Discord thing. All right, any other questions? Okay, so if you have questions about the machine, how it works, things that you don't understand, make sure to find a TA. That's probably the most effective, is to try to go to an office hour of one of the TAs. And maybe you can either meet in World on the TA Treehouse or over Zoom, and you can clarify that, okay? All right. So I am going to end the lecture here. I'm going to stick around another 10 minutes in World. Um, Howard has a question. What do you submit? So what you submit is to put your 3 programs in 3 separate plain text files. So you're going to, once you are, done with the programs, everything is working, what you should do is go here, copy this, all right, get a notepad on your computer, and paste it onto a notepad on your computer, save that file, all right, and then you're going to zip the 3 plain text files and upload the zip file onto Canvas. So this time is not a picture, it's an actual file, or 3 files. There was another question over here. When will we get the grades of our quiz back? I think very soon. I think it's just the reader is just finalizing, removing some points from the people who turned it in late. I hope that for this next quiz I have fixed the problem and you will be able to see your grade immediately, okay? Hopefully. The due date for the project, very well. So the due date is, where is the due date? Oh, January 24. All right, January 24. So Brandon is asking, will we be told how to write the programs? No, so I'm not going to tell you how to write every specific program. I'm going to explain to you what these instructions do, right? Each of these instructions. I'm going to have some example programs of how to use those instructions, and then it's up to you to figure out how are you going to do that particular thing using your knowledge that you acquired about how the instructions work. Okay, and I know this can be very foreign, and the first time that you write the program can be very confusing. So if you really don't know where to start, the best is probably to go see the TA. Okay, go see the TA and ask for help about where to start. All right. Yes, so I will tape some videos explaining the instruction set. I think you guys need it if you want to start doing it. I was planning to cover it next week, but I'm seeing here that you are eager to start, so I'll probably tape the video before next week. Okay, so again, logistics. If you go to your treehouse and you find somebody else's object in there, let me know. I can actually go there and I'll check that your object was there first, and I will remove it. Okay, so Jenny, I'll write it down. That's it for today's lecture. You are all dismissed. How to put the greeting on my lawn. So Ruomo, I'm going to explain one more time, okay? So you're going to go to open your inventory. So, and again, your inventory, bye everybody. Your inventory is found here. I'm not streaming, hold on. Here, this thing. So I'm going to open my inventory, which is this button over here on the bottom, this suitcase, okay? Find the object, which should be somewhere in a folder called objects. Find a folder called objects, and it should be an object there called taken. All right? And then once you find that object, click on it and drag it onto the lawn. Just drag it onto the floor. Okay, this is how you put okay, Fatima. The treehouse is missing. Okay, so here's what I'm going to do. I'm going to stop streaming and I'm going to help some people in World directly, okay? Bye, everybody. See you next week.